I don't know what happened there.
I don't know. We are very sorry for starting late. We had some technical issues. I'm Yasmin also. I am one of the EU Code Week ambassadors in the UK. This is our first EU Code Week event. And if you haven't heard about EU Code Week, it's a initiative supported by EU Commission. And if you'd like to find more about EU Code Week or find an event near you, please visit Code Week EU website and you will find a list of events that are running near you. Or if you'd like to add an event, please do so. Now, today we have Phil Bagge from UK. As an educator, I know Phil very well, and I think I cannot imagine any educator in the UK that wouldn't know Phil or his website. He's one of the, I would say, leading names in terms of computer science education in the UK. I'm going to let Phil to introduce himself.
Lovely. Oh, Yasmin, it's really nice to be here and to join in and have a really good chat. As excellent. Apologies for any technical issues. I don't know whether they were my end or your end, but if they were my end, I apologise. Just really nice to be here. My name's Phil Bagge. I for the last 2 years. Shall I give you a quick spiel about what I've been involved in? Does that sound all right, Yasmin?
Yes, please. Yes, please.
Yeah. Now, about 3 or 4 years back, I was looking for something to really stimulate the pupils that I was teaching, and at that point I was really finding that although I was really enjoying doing all the ICT, I felt that there was just not really enough challenge to the curriculum. So at that point, I was looking around for something which would really sort of give us that sort of extra zing, really. And I basically bumped into CAS, Computing at Schools. And at that point, it was just a mailing list with about 1,000 people on that mailing list. And I found some real interest. You know, I listened to lots of ideas, doing some coding, doing some programming, getting these things back into education. And I really enjoyed the group, and I started getting involved. And I decided in some ways, I thought, right, okay, let's really risk this. So I actually approached a whole set of head teachers in Hampshire, and I asked them if they'd be happy to employ me for a day a week or half a day to teach them computing science. And I think at that time most of them probably thought I was mad, or more to the point, they probably thought, well, he's an advanced skills teacher in ICT. We'll at least get a nicely designed ICT curriculum out of him. And I thoroughly enjoyed going and doing that, and in the process got involved in a little bit of the drafting stages of the new national curriculum, met lots of friends, and really discovered just how wonderful the challenge could be and how much children really enjoyed it, creating, coding, thinking through things, and making things on the computer. So it's just been a wonderful roller coaster ride over the last few years, really.
But we are in the UK, and I think in the Europe, we are kind of at the beginning of a very exciting journey, but it's very challenging as well. If you're a teacher or even just an educator who wants to start teaching computer science and programming concepts to young children, it's quite difficult to know exactly where to start. Especially if you're not into programming, coding, game design yourself, it's quite scary. What would you suggest? How should we start?
Yeah, I think sometimes probably more important really is to start maybe with some unplugged resources. I've got a couple of things which got me really thinking early on. And one of those is looking at the idea of algorithms, which is the idea of breaking things up into small, manageable chunks. And it's also the idea of thinking through something you want to make on a computer. And I have a little activity called the jam sandwich.
Oh, that is, I think, probably the most popular activity in the UK, thanks to you. We even call you Jam Man. The jam company should give you sponsorship.
Well, I must admit there is probably a trail of jam sales everywhere I go, and that's that. I mean, it's been amazing, really. Just this whole idea of getting what I wanted was for children to think through things in very sort of small segments, really, and think about being very precise in the language that they use. So getting the children to actually give you instructions to create the jam sandwich was wonderful. And actually, I've been really lucky. In fact, even today I had a tweet from a gentleman in Poland who had been doing it. I know it's gone to New York. I had a very nice tweet from a teacher in New York, and I know it was recently converted into Dutch.
Oh, wow.
A week of code over there, which was wonderful.
That's brilliant.
But I mean, there's a little video which I know you linked to this, which sort of shows people, I think, some of the sort of hilarious outtakes.
I use it for teaching in our lessons at the university, and the students, they absolutely, I think, understand what we're trying to teach youngsters through coding, through that simple video, I think.
Yeah, there's something really magical about the whole sort of precision aspect of that. I mean, that I think was really good. There's a few other sort of unplugged activities that I've really enjoyed. I do a little thing with my children where we get them to think about writing an algorithm for getting up in the morning and getting to school, and you get this real sort of disdain first of all, thinking, we have to do this, and then they start doing it, and they realise that actually it's a lot more difficult, because they say things like, oh, I get up and then I have breakfast, and I say, wow, so breakfast is right next to your bed, and they go, oh, no, I've got to go downstairs. Oh, so there are some more steps to this that you need to really logically think through the steps for that, and certainly the whole sort of elements of everyday algorithms, thinking through things that people do every day. I mean, I know some teachers who have done things, how do you use your dinner queue system at school? Can you write an algorithm to actually send someone through your canteen system? And then they've given it to their friends, and their friends have actually gone through this, and they've spotted where there's a problem or an issue. Oh, you forgot to pick up knives and forks. Oh dear, and all of those sort of things. So certainly, and thinking through those sort of precise steps is really good. And also, I think that enables us to take those next steps on, which is to be quite precise when we're thinking through some basic programming as well. Which is really good.
What do you think? What programming concepts we are looking at in primary?
Yeah, well, I think very early on, we've got some very simple things around sort of sequences first, and people often think, oh my goodness, we've got to get something new that we've never used before. But actually, I mean, I've been recently working and using a lot of the B-bots, those tiny little. Oh, have I got one in my room? Well, I have. My daughter's nicked it. As well. So just using those little digital devices. Here we go. There's a picture of Bebop box, if nothing else. And actually just thinking through the sequences of instructions to program them from one sort of location on the mat to another location on the mat, using little cards that you put down to say what the steps are beforehand, and that in itself can be a sequence of instructions that you're giving. And then there's some wonderful extension that you can do from that. And if you haven't seen any of these Bebop mats, you can make them yourself or you can buy them, and there's sort of a grid, and they'll have things like a map of a farmland with a farm and shops and things like that, a little bit of a road, and then you might say, well, okay, how many different routes can you work out to go to there? And the children will, they'll put down some different routes, and then you might ask them, well, what's the best route and why? And then they start thinking, oh, well, what is the best route? And is it the one which Bebop gets there the quickest? Is it the one that gets there in the shortest distance of time? And while they're doing things like that, they're sort of evaluating their algorithms and thinking through what's going on. So I think the act of programming is important, but the actual act of evaluating and thinking through that is just as important, really, especially in the early stages. But that doesn't happen overnight. That you need time for that in Key Stage 1. It's quite a process, really. And I do have a progression of activities for things like the Bbot and the Roma 2s with the very simple interface. I've just put that on my website quite recently.
So I'm hoping you will take us through your website, because I'm sure we can do screen share on this program. So it will be nice to walk us through your website and activities, resources you have there. That will be very useful as well. So if we start with unplugged activities and we're looking at the simple programming concepts, then how do we move them into more complex thinking?
Yeah, I think, well, obviously, we've got in the national curriculum in England anyway, we've got this idea of moving from sequence into using things like selection, which is about making choices. I have some I tend to, especially in Key Stage 2, I do a lot of Scratch work, mainly because Scratch has the wonderful benefits of being online and free. And I think that's it means the children can learn in their own time as well. And I've certainly had classes where those children have actually been part working at home and part working at school, which is wonderful. So I think all of that's really good. Really, really well-defined system. What I tend to do is I'll start them off with some very simple sequencing type activities, which just get the idea of, yes, we can make certain keys on the keyboard do things, or we can make certain mouse clicks do things. So we're still at that very simple sequence level of things. And as part of that, we want some exploration too. So, I mean, I'm showing them things, and I'm also encouraging them to come up with, oh, what can you do? What can you attach? What can you make different buttons on the keyboard do as well, which is really quite exciting. And then we get into sort of thinking about selection, and I have a couple of things that I do for that. Both of which are on my website as well. One is we do a very simple slug trail game. And that's really good because it introduces some basic repeat loops, which are good as well, and things shoot across and they follow the mouse as well, which the pupils absolutely love. Draw some lines, and then we get into some little selection bits that we can use with that as well. So we have our slug going in and out of the trail, and when he's in the trail, he says, "Oh, lovely," and when he's outside of the trail, goes, "Oh no," and that's just using a very simple selection block. And then what I do is, and in fact I haven't published this yet, but I will put it up very soon, is I give the children a background with, or they make a background with lots and lots of different colours on it. And we use the lovely little Scratch block which talks about if touching a colour. And that's a nice little condition. So if touching a colour, and then they go and they link that to all the different colours, and they go and find as many different things that they can find that they can actually make it do. So, you know, we'll get one child, if touching colour red, it'll spin the sprite round. If touching colour yellow, it changes it to a sort of fisheye view. If touching colour green, it does a sound. And so they're going and exploring and finding as many different ways of using selection in fun ways. And I've so thoroughly enjoyed seeing them sort of. What is
all this passion that coming out of you while you are even explaining?
Yeah, it's just lovely to see them grow, and I think what we're doing is we're building expertise that when they come on to creating things, whole things for themselves, they've got sort of real understanding of some of these things as well, through quite a few projects. I know a lot of. I know that some people would sort of almost encourage we jump into one thing and then we jump into another and then jump into another. I'm a big one for having one strand of one type of programming all the way through a key stage. That's not to say that I don't think we should jump into other things, but I want the children to develop depth, and they only develop depth by doing something over a period of time in a similar way.
Well, on your website, and I know in many websites as well, you have also some textual coding programming resources such as Python.
Mm.
What do you think? Is it okay to start textual coding in primary? How did you start? What kind of activities you did?
Yeah, I think you've got to look at where the children are, and I mean it's very interesting. I've done that with about four out of the 5 schools I taught for the last 2 years. I did some Python programming. Now I thoroughly enjoyed what we did, and I think there are some real value to some of the sort of syntax issues and thinking that through and trying to find errors and all sorts of things. And I think also children do value that at a higher level because it looks like something that is real programming to them. So I think it, and when the first time you make a real window that looks like something on, you know, Microsoft Windows or Mac or whatever you're making it in, that's a real sort of buzz. And I think they're sort of connecting it sort of with that in a very much more sort of. But I've also found that in some ways I would often I prefer. It's funny, in the last year I've been doing more Scratch because I've been developing a greater depth in that. And I found that even my coders who are very good at Python in Year 6 would go back and use Scratch as almost like a test bed before they made something elsewhere. So it's quite interesting. And I personally, although I think you can teach Python in Year 6, and depending on your sort of children and where they're at, I think for most general primary school teachers, I think we will probably end up that's probably a bridge too far in terms of their own expertise, because it probably took me 6 months to a year to get my head around the very basics of that. And I suspect most primary school teachers haven't quite got that amount of time, unless you're a specialist. If you're a specialist just teaching that, and then I think go for it, and it can be really good.
What about HTML?
Yeah, it was interesting actually. I think, you know, certainly in terms of using some HTML, it's good. I mean, I very much HTML I don't see as coding. I mean, I see it as
yes, that's what people usually say.
Yeah, I mean, I see it as a really interesting way of understanding the web, and I think we have opportunities to include that in the curriculum through some of the strands in England. Obviously, you can add to that and do what you want, and I think that's important. But you know, in terms of sticking to the curriculum, I think you have opportunities for that. I've actually been experimenting recently with a little bit of JavaScript as well, because obviously that is real, you know, that's proper coding. But I'm very early stages with that, and I wouldn't say I was at that point of having a go at anything with any of my primary pupils yet. I suspect, generally speaking, that also is probably something that's more Key Stage 3, Key Stage 4 onwards.
What would be nice is if you could take us to your website and show sample activities that we can do during EU Code Week and another time. Because when I go on your website, sometimes there are so many activities, and I'm thinking, I wonder which one shall I do?
Now, I'm going to have to see if I can work out which buttons. Screen share, do you think that's
that should work? Yeah.
Let's try this, and I shall go for, let's share the content screen. What would you like, sir? Let's go for the entire screen.
Yeah, and then we can learn about your website.
Okay, so hopefully I'm screen sharing at the moment.
Yes, you are at the moment.
Let's go and find my website here. Here we go. Can you see that all right?
Yes.
Fantastic. I'll just zoom in on that a little bit so that we can control. There we go. That's a bit better. So most of my computing science activities on this CS planning page here, and there are sort of a wealth of different things that might be useful for you. I mentioned earlier on my Key Stage 1 Turtle, Bebot and Roma progression framework. So this is not a scheme of work so much. This is really looking at how you could build a scheme of work and giving you ideas that you could use to underline this. So here we go. This is just the PDF of this. I pretty much do everything in PDFs because it makes it easier. So there's a whole lot of play in there, which I think is really important. And then you and your pupils getting an idea of what every button does. Things like turtle marbles and some of the simple A to B. A to B, creating symbol algorithms first, putting down those cards, thinking about it, and then from A to B, avoiding C, those sort of things. The best route, which we sort of talked about earlier. Unfinished algorithms, having an algorithm that isn't quite finished. Can the children work out what's missing? And then some of the sort of turtle maze ideas of, well, you've got a maze, you can work out how to get there, but what's the best route? What's the quickest route? And evaluating those as well. So there's a quick something that I've just been working on quite recently.
I think that is brilliant in terms of if you're planning a set of lessons.
Yes.
Using them as a stepping stones.
Yeah, because I very much feel that what teachers need for something like the Bebot is not me to give them great big downloadable resources with grids to print out and all the rest of it. I think most Key Stage 1 teachers have already used Bebots. I think it's probably more important just to give them a framework of questions for the sort of computing science side of things, so that they can actually really sort of go and think, oh yes, okay, well, my topic is around the farmyard. Well, let's do something there, or my topic's around whatever people are doing really, and I think that's probably more important.
And it's more relevant, isn't it, if you could do cross-curricular rather than just as isolated computing lessons?
Yes, that's right. And I think actually teachers are very good at finding context for things. I don't think that needs me to sort of step in and explain context. I'll show you something else here. This is a human crane activity. So what we've got here is an activity where the children, this is another unplugged activity. What happens here is we've got lots and lots of cards that the children can print out, which have things like open and up and close, and they're all sort of simple actions. And what they've got is a whole set of, you'd have 3 bowls and some blocks that you put in the bowls, and it starts off with how can we make an algorithm to move one block from one bowl to another bowl. And it gets more and more complex. There are 12 challenges in there, and in fact I've had some quite good feedback from Key Stage 1, but I've also had feedback from Key Stage 2 teachers who have said, well, actually our children haven't got any experience of doing things like this because they won't have done it in Key Stage 1, and so actually we've gone back and done some of those sort of Key Stage 1 activities with Key Stage 2 at the moment, and they worked really well. So yeah.
Well, Phil, you'll be surprised because we are using your activity, your human crane activity, on Wednesday for our event at Mozilla, and I already received a few emails asking me about description of the activity, who won't be able to attend, and now I know where to direct them.
Good. Oh, I'm glad that's useful. Now let's just go back a little bit, and
I can see you still have logo.
Yeah, do you know, I'm a big fan of logo. I very much think I have a couple of modules of logo planning, and although people often think, oh Phil, you push Scratch all the time, I think I tell you what I have discovered over the years. Although you can do things that draw shapes and lines in Scratch, so you have got a pen down command, and you have got a line drawing and angles and all sorts of things. You can do that in Scratch. What I found is that it is far better to do those sort of things in logo. And I think what it is that it's about the fact that actually in logo, those things are, children don't have lots of buttons they can choose. So they only really use the ones that you've told them about. So that might be in the early stages, things like forward and back and right and left and pen up and pen down and clear. And that might be all you've given them to start with. So it means that you can keep them really focused on what they're trying to achieve in terms of the logo work. And also I can combine this with lots and lots of human robot activities. So lots of getting out into the playground and pretending to be robots, being robots in the classroom, planning a route across the classroom, cutting while somebody else gives you instructions, drawing things while someone else tells you how to chalk it. And a lot of those ideas are actually really quite old ideas. They're ideas really that that someone like Seymour Papert, who actually thought of invented logo, would recognise straight away. And I think, and then it's only after we've done a lot of those things and got ourselves used to the language of angles, the language of line drawing, then we actually get on and do a little bit of programming. And you can see here a picture of some of our early work where the children will mark on things on the floor, we'll get the children walking and writing their algorithms as they go, and then they'll take that, their set of instructions, they're going type that into whatever logo program they're using. And the lovely thing about that is if it doesn't produce the shape on the floor, they know that something's wrong, but they can go back physically onto the shape and actually go, oh, okay, we need to go back to that physical action on the floor and go and debug our code. And that I found really, really powerful. So, but when I've tried these things in Scratch, although the children can do them, they get very distracted by all of the different extra buttons that you've got in Scratch. So very quickly it becomes who can draw the fattest line and who can draw the best background color and all sorts of other things. So they lose, sometimes they lose that focus because Scratch almost has too much. Does that make sense?
Yes, yes, and I think you can teach the fundamentals of programming by just using logo as well, as long as you design engaging activities.
Yes, yes.
It's all about the activities that we do rather than just the program itself.
Definitely. In fact, I've got a module that I've done for both logo and Scratch, and it's called here I think it's probably just here. It's a logo tree program. So, and I've actually written a Scratch version of this as well. And the idea is that the children have to design their own tree that draws different branches every time.
Wow.
And it's not an easy bit of planning, and it's really sort of year 5, 6, once children have done quite a bit of programming beforehand, really. But I've done this both in Logo and I've done it in Scratch as well. And
it's good to compare as well how both programs works as well, how you can achieve the same task using different programs.
Yeah, I mean, definitely. What was interesting to me though is how much more the children enjoyed it in Logo than they enjoyed it in Scratch. Almost universally, the 2 classes I did this with, or when I gave them a choice, do we want to go and do this in Scratch or Logo? And they love Scratch for lots of other things, but they all wanted to go and do it in Logo. So
that is interesting.
That was really interesting to me. I didn't expect that when I first did that, but yeah, that was quite interesting.
Well, that is quite good because we can give a message from here to teachers. They don't just have to stick with Scratch or just one program. They can look at the other alternatives as well. And Logo is definitely something I think any teacher should try using it with their class.
Yes, definitely. I love Logo. It's been interesting. Sometimes people have said, Logo's just not 20s. It doesn't look wonderfully bright and engaging like Scratch does, but there is some really, there is some real benefit from plugging in small modules of Logo as well. I rate it highly. Should I just go over some of my Scratch resources as well? Or?
Yes, please. That will be good.
So what I have here, pretty much underneath this, is a primary Scratch plan, and these are things that I've taught over the last few years. I am constantly upgrading and improving this. In fact, I went to a school today, Westfields, with Corinne George, who's a lovely head teacher, who let me use her wonderful video conferencing. So they videoed me teaching one of my lessons, basically the smoking car one up here, and I did it in a very different way than I normally would. In fact, we're hoping we will be able to share some of those videos eventually. So that's really good. So what I've got is some very basic introductory things like the smoking car, music machine, dressing up program, basic conversations, which really are easy enough to do in year 3. They're not very complex, and they're also quite easy for teachers who are unconfident about this. They're quite easy ones to pick up.
I think that is brilliant.
So I'll just click into one and just give you a little taste here. Let's just go into the smoking car. I mean, I include with a lot of mine the planning, but I also include learning intentions, success criteria, and what I hope for teachers is that they can download these in Word and change them a little bit as they grow and they adapt what they're doing as well. I get the children to fill in smiley faces on these at the end of the session for each week, just to give me an idea of where they think they've got to and the areas they've struggled with, what they've done really well. I also go round and I annotate these sheets, so when I see a child really trying something new or pushing the boundaries a little bit, I will just put a little symbol on there just to indicate that. And when I see children really struggling, then I'll put a different type of symbol just to indicate that as well. And I found that really useful for myself to keep an eye of, well, who do I need to pick up next session? Who do I need to maybe make a little group and go back over some of these things with, because they haven't got it fully the first time. So, you know, that's been really useful as well. I also put a lot of catch-up cards, and sometimes I use these and sometimes I don't. And basically these are little cards that we have so many children who go out for booster lessons and then they miss part of the lesson. So
what a good idea.
Sorry?
What a great idea.
Yeah, well, it means the teacher can print these out, use them to support children who are debugging work or support children who have missed things because they've been out on boosters. And you just fold these up and you can use them with the children however you want to. And some lessons we don't use them at all, and other lessons they're really useful. Just depends on what's going on. And then if we go briefly, I'll go on to the printable planning. I'll see if I can zoom in on this a bit better. And I use a learning pathway here. In fact, I've just updated this one quite recently to put in a couple of endings. So most of the children will expect them to go along that 1, 2, 3, 4, 5, 6, 7 pathway, but there are also extension activities for those children who are ready for them, and the catch-up cards as well for those children who need those. And we've added some sequence work at the end, which I found really good for children, getting them to plan a whole sequence of instructions, make a bit more of a complex bit of coding to get there.
It seems to me you've done all the work.
Yeah, I mean,
some teachers just need to go in and teach.
Yeah, it's true, but I also think that there is a danger with that. So what I really hope people do is that they take this. Yes, in the early stages, I think there's going to be a lot of teachers who are going to need this sort of hand holding. But what really excites me is when someone comes back and says, "Oh, we took your planning and then we tweaked it, or we changed it a bit." And I mean, I had a lovely Twitter conversation with a lady who had been doing my crane work recently, and she was talking about how they'd added some extra bits on the end of that, and I thought, fantastic. And I really hope that people take these ideas and make them their own and change them. But that only really comes as people get more confident, really.
I think what is great about your resources is it clearly states what kind of concepts we need to focus on by doing that activity, and how we can assess it, how we can achieve the tasks. Everything is clearly stated, so it makes it easier for someone who is not familiar with coding and programming to get familiar with the concepts before they go in and teach the whole class.
Yeah, no, that is totally true. I mean, one of the things that for me is very important, and in fact I wrote an article on this recently, is the whole thing of computational thinking in the primary curriculum. So and that's been really important for me. So and there's a wonderful document. I've got to plug this document because I think it's absolutely brilliant. Written by John Woolard and of Southampton University, and Mark Dorling and Cynthia Selby and a group of them. In fact, it's here on my link for number 7 there. Okay, and this has a link to a wonderful document that really what they've done is they've taken some key computational thinking ideas, things like generalization, abstraction, decomposition, evaluation, algorithmic thinking, and they've broken these up into questions to use when you're planning, when you're thinking about what to do. And that has been fantastic. I mean, I was very aware of things like algorithmic thinking, decomposition and abstraction generalization, but the whole aspect of evaluation and evaluating algorithms, that document is brilliant at bringing this out really and expanding on that and making it really sort of obvious. And I would encourage everybody to go and have a read of that document. Lots of my planning recently, I've been putting it as extra links at the end of it, because ultimately what we want is for people to think this through themselves really. But that takes time. I understand that.
Can we quickly describe computational thinking? Because of course we are talking about coding and programming concepts, but the bigger picture is we are trying to help children to develop computational thinking rather than just making games. There's a behind the scene agenda that we have. What do we mean by computational thinking? Because it's not being talked or discussed in every single country as we had in the UK. What are we trying to achieve? What is this, I would say, trendy word, computational thinking?
Well, I think first of all, I mean that's a really good question. I think first of all we have to understand what computational thinking is really, and there's a lovely description of computational thinking, and it's an American description from, and I've forgotten the name of the group, although it is in my article if you want to go and find it out. And it talks about the power of critical thinking plus the power of computing. So it's critical thinking that has developed out of the power of computing and with the power of computing, and it's thinking skills which are important for that. And I like that definition because I think it's very tempting sometimes to have a look at critical computational thinking and sort of take it totally away from programming and things that you do on a computer. And actually, although we sometimes use these things outside, their importance is their importance for the power of computing really. So we've got things like algorithms, creating a precise set of instructions to accomplish something. And as part of that, we've got things like, well, how can algorithms be expressed? Well, algorithms really are around about the thinking through. Every time you make a program, every time you make something on a computer, that has to come from somewhere, and it doesn't magically appear. You start moving some scratch blocks around. Those are ideas that people have thought of, and for younger children that might be just a case. In fact, today we were thinking about what could we make our car do. So what we did is they've got a lovely wall at the school I was, and they can write all over the wall. So, which is fantastic. Children love that. And so the children went and drew some cars, and then they thought about what would I want my car to do? What does a normal car do? And they came up with things like moving and steering and leaving an oily trail behind, and all sorts of strange things like flying and. But what are they doing?
Imagination.
Yeah, and what they're really doing there is they're sort of prototype algorithmic thinking. They think, well, what do I want my program to do? And then, of course, once all programming is in effect turning an algorithm and making it into code. So in fact, what we then did is we went and introduced them to Scratch. We introduced them to the idea of the very simple keyboard inputs, that we could make keys on the keyboard, do things on the computer, and then they went and discovered some of those aspects and made their car move and turn and say things and all sorts of things. And for a lot of them, although there wasn't a lot of precision in that algorithm, there is that principle of taking their ideas and turning them into code and their thinking. But I think it's also important to say that not all algorithms need to be written down and expressed. There are lots of occasions, especially in the early stages where you're thinking about sequences and simple aspects of programming, that really these are ideas that you've got in your head and you're getting out onto the, and that is algorithmic thinking, because you're thinking through what to do and then you're creating that on the computer. I mean, I do also use things like flowcharts, and I've got a lovely resource, and I'd really recommend anyone to have a go at this. In fact, I've had teachers come back and say that they've had outstanding lessons on this as well.
On your website?
Yes. What it is, it's to do with playground games. So what we do, it's on that same page that we had before. So we take the children out, and what I discovered with working with flowcharts is that actually, if you try and create a flowchart when you've never really used one, you end up creating a pretty poor flowchart, and the lesson bombs pretty quickly. And funnily enough, that's very true of literacy. You know, your reading skills go before your writing skills. And actually, I should have known that, really, being a primary school teacher of 20+ years. So very interesting. So what we did is I realised that after having a couple of lessons that really sort of bombed, so I made some flowcharts of simple playground games, things like pig in the middle and stuck in the mud and things like that. And we get the children outside in groups of 4 and 5, and I wouldn't teach them anything about flowcharts at all. All I'd say is I'd give them the flowchart and I'd just say, right, start at start. That's all, because it's got start on there. And I say, all you've got to do is you've got to work with you and your 3 or 4 friends, and you've got to work out what this is making you do. And when you've worked it out, you can play it yourself. Now that's an impetus for children in a lesson, if ever there was. So the children would, and in year 3 and year 4, it would take them quite a while to work out what they were, and then they'd go and play it and thoroughly enjoy it. And in year 5, children would do this in, I don't know, 30 seconds, and then they'd off to play it. And then what we would do is we would take the children back into class, and I would give them a bugged version of this. Now this is exactly the same flowchart, but it's got one line, one connection that's in the wrong place. And I've had some lovely lessons with children working their way through, and there are some easier ones, and they get harder and harder and harder. And just the amount of thinking that goes on with something like that, just the children. I mean, I had one girl at one school, really good mathematician, and she got 4 of them right out of the 5. And she got stuck on the 5th, and she accused me of cheating. She accused me of giving her something that didn't have a bug in it. She stamped her feet. She got really cross. She got frustrated. And I said, no, it's all in there. You've got to sort it out. And by the end of the lesson, she got it about 2 minutes before the end of the lesson. And it's the only lesson she's ever come up and actually thanked me for at the end of it, which says something to me, actually. So I think children need experience of reading flowcharts before they can create something, really. Yeah. And certainly in some of my planning modules, I have partly completed flowcharts that children have to spot the patterns, because pattern recognition can be something else that's also part of computational thinking as well. So children have to work out the pattern, and then they have to complete that pattern, and then they have to use the completed flowchart to help them.
It's interesting because it's also part of mathematics, so there are lots of links between mathematics and the computing.
Yeah, I mean, that has been one of the most wonderful things, actually, just seeing. What's been really interesting to me is we've also, where I work with lots of schools and where I'm often modelling a lesson for the teacher, it's been very interesting to talk to the teachers about the children's mathematical ability as well. And we were doing one lesson around perimeter, calculating regular perimeters, and it's a module on my scratch plane. And we were doing this in year 4, and there was an extension which was to calculate the perimeter of a rectangle. And I had we had right at the end of the lesson, we had about 4 children solve this out of about 10 or 12 who'd got that far. And the teacher said, "That's really interesting, Phil." She said, "None of those children are in my top math set. And none of them, they're not even in the second math set, they're in the middle math set. What's going on here? How comes they've solved it when some of the other children who are in the higher math sets are really struggling?" Now, you can't make a whole thesis from 3 children, but what I was quite interested to see, I have a little theory, and I think it needs more testing, which is that some children are very interested in the arithmetic side of things, and some children are sort of interested in how things work. And something like that, where you're getting the computer to do the maths for you, but you have to understand how it works, you know, really appealed to some of the children. Also, the slightly subversive thing of saying, well, I mean, when we do some of this, I talk to the children, I say, well, look, we can get the computer to do the maths for us. And they're like, really, Mr. Bagge, are we allowed to do that? Yeah, shh, don't tell the head teacher. And they're doing some wonderful maths and they don't realise it. And I think that's wonderful, really.
What I liked is when you were showing the activities on your website, one of them had a sheet where the child could check on themselves, whether they're following the correct route, if they achieve what they were expected to achieve. It's kind of like encourages them to regulate their own learning, isn't it? Be master of their own learning process rather than waiting for someone to come and say, yeah, you're doing right, or oh no, you're not doing right. It's kind of like gives them the power. Yeah,
I mean, I think it's interesting. I've been on a real journey with all of this as well. And my earliest programming was very do this, do this, do this, do this, do this, do this, do this. And, you know, that proved to me that actually children could do it. But in the last year, I've been very much on a journey of saying, well, okay, can we get a little bit more self-discovery in this? Can we get children to... Now, there are things that I think you have to teach. You have to teach selection. Very, very few children will work that out for themselves. Variable use, very few children will work that out for themselves. Some of the ways of using repeat loops and things inside repeat loops, very few children. But there are real ways, once children have seen one example of this, to give them ways of finding other examples and get them into this. And I'm very much on a journey, probably for about a year now, really, of adapting quite a lot of my resources and thinking, well, okay, how can we discover this for ourselves? And actually, it's my biggest bugbear is just not having enough time half the time to write all of this stuff up. There are so many modules that I teach in a slightly different way now. I will often give children, say, well, can you work out how to find that and make that work first? And actually 50–60% of the class will often manage to come up with a solution, and then I will go through and help those who haven't managed to come up with a solution, or direct them, or give them clues. In fact, I do a lot of teaching now where I will start off with something and then I'll give the children clues, the next little step, or a part fix, or a part, oh, why don't you think about this block, or that, and then some of them will pick it up along the way, you know, but it's getting them into the sort of the creation aspect of this as well, which I think is, you know, really important. And that's yeah.
You mentioned variables, and I think that is one of the trickiest thing to teach, especially to young children.
Yeah.
How would you introduce variables to children?
Well, I think that the easiest way early on, I mean, I have a little module which is to do with creating a quiz, and in fact, I mean, that I must video me teaching that, because it's just one of those things that
you can always teach us. We can film you.
Yeah.
You can come to university and teach us.
So that's been really exciting, really, because you have to work through the algorithm first. You have to think about how you ask questions, and how you feedback answers and what you do yourself as a human, really. And then from that, you can create some wonderful bits of code using Scratch. I mean, in fact, you can do it just as easily in Python, to be honest, but that's another issue. And then as part of that, once we've got a set of questions, we'll talk about, well, what's missing from this? And nearly always children will come up with the score. And that is often a really simple way of introducing a variable. So, and what I do is I will introduce this idea of the fact that, you know, and you have to ask children things like, well, you know, if I've got a 5-question quiz and there's 1 point for every right answer, do I know what the score will be before you take my quiz? And I know that sounds a silly question, but there will be some children who will think that it's almost predetermined. They've not thought through it enough to realise that there is a possibility of you getting nothing. There is a possibility of getting 1 mark or 2 marks or 3 marks or 4 marks or 5 marks. And once they realise that actually it is possible to get a range of answers, then it makes a lot more sense that then you can introduce a variable called score or points to actually hold the points. And then what I do is I model that using often pots and pencils or boxes and blocks, something the children can see, and we will put in a pencil into the pot for adding, increasing the variable by 1, and we'll very physically do that, and then we'll we'll often have a child to help me, and they'll look in the pot and tell you what's in the pot, you know. So it's those really sort of, I think it's so important to sort of physically model things as you go, really. And so that's really good. And the other way I introduce things is we look at, in fact, on the perimeter work that I've got, I have a PowerPoint which I use with children in class beforehand, and what we do is we look at some basic 3 or 4 sums, and we look at the idea of a variable being something that's changeable. And so we look at 3 or 4 sums which are all multiplication sums, and we look at what numbers are variable, are different in each one, and then we talk about the fact that we can actually swap those for something that's called something that holds, or basically a variable. And I get the children to go away and write some simple formulas from that. And actually that's been really successful in year 5 and 6. So they will go and write some very simple formulas just for any number times 2 equals the answer as a variable, and the first number is a variable. And then what we'll do is when we go and actually create the perimeter program, at the point where we get to the line which actually does that, I'll say, right, where are your formulas you went and created? Right, let's take those out, because they're what you've got to change into code. And actually, lots of children can do it at that point because they've already thought through the changing those numbers into something else, and then they can, you know, approach that. So that whole idea of a formula being, you know, that's an algorithm as well. That's been really useful. That's worked really well with the children I've done that with.
I think I wish that I had your knowledge and experience.
Yeah, I must admit, it's funny because I think a lot of where I'm at, I worked out recently that I've taught over 1,100 hours of primary computing science in the last 2 years. So what I think for myself is, yeah, okay, I've done a lot of that, so I'm probably going to have picked up a lot of things. But and most teachers at this point, you know, if it's the first year of the new national curriculum, yes, really are going to be at the stage, especially let's take Key Stage 2 for a start, you know, 7 to 11-year-olds. They're going to be at the stage of that children haven't done any of this before. And it's really important not to jump ahead and try and do much too complicated things. Now, I've done that and been burnt in the past. So it's really important to start children with really simple things early on. You know, it's a little bit like trying to do long multiplication when children haven't got a number system in place. Yeah. So it's a
very good example, actually.
Yeah. So I would advocate things like doing the smoking car, the music machine. They're very simple. They take children in at an easy way, and they also are really good for teachers as well, because teachers can learn at the same time as the children. And,
exactly.
And actually, I've done those with year 3, 4, 5 and 6. And yes, in a year 6 class, it might only take a lesson. In year 3, it might take 3. But it gives them a bit more foundation of keyboard inputs and making, and then when we go on a more complex work, it's easier for the children to fall back. They've got some depth, which I think is really important.
I think this has been a really useful session for me, and I can assume that those around Europe, I'm not only thinking about the UK, who are at the beginning of their journey for teaching programming, and I think not only the ideas that you shared in here, but knowing that your website is here, there, and they can go back and explore it anytime they like and try the activities out for themselves. I think that is the the most useful thing that we shared today, and I think that's brilliant.
No, that's lovely, and it's just really lovely to be able to share. I feel very privileged, really, to have spotted this so early on, really, and got in. And
I think we're very lucky. We are very lucky to have you. We are very lucky to have. There are a few individuals, I think, in the UK who led the way for all of us. We are very lucky to have you. We are very lucky to have Miles. I always mention we are very lucky to have Computing at School, who also led the way for us. And Code Club, who is also leading the way, and sharing these examples with rest of the Europe might help them to, get ideas of how we started, how we are moving on. Might help them as well, I think. But thank you so much for spending your hour with us. I know you're very busy.
Oh, Yasmin, it's been absolutely lovely to talk to you again, see you again. And just to say that people are very welcome to use any of my resources. I know a few countries have come back and asked me to, if I'm happy for them to translate them into something else. And I'm more than happy with that, as long as people, reference back to the original.
There is your contact details on the website, isn't it?
Yes, contact details on the website, and anything that's useful, please, they're out there to be used.
So we are wishing happy coding to
definitely have a great
coding to whole Europe. But we also want people to remember that by coding, we're not just learning a computer language. What we're doing is we are unleashing our creativity in the process of making something through our thinking. So it's more than just learning a language. There is always behind the scene for everything. And so happy coding Europe.
Yes, most definitely. Thank you.
Thank you.